Hey, this is Mr. Beckstrom, and today we're going to be looking at section 2.6. This is mathematical models building functions, and this is definitely kind of a jump in the more complicated math that we're going to be looking at this semester. So I definitely wanted to do one of these, and there's a lot of parts to it, and it's pretty easy to get confused in these different parts. So I just want to go step by step and show you how we would do one of these types of problems. All right, so it says two cars are approaching an intersection. One is 3 miles south of the intersection and is moving at a constant speed of 15 miles per hour. So let's, as we're writing or reading this, let's go ahead and write this. So we have some intersection here, and we have 3 miles south. So 3 miles south. Right here, we've got a car that's moving towards that intersection. So this is a distance of 3, and it's moving at the intersection of 15 miles per hour. So right here, I'm going to put this is 15 miles per hour. All right. At the same time, the other car is 2 miles east. So let's go ahead and do a little bit shorter of a line here. This is going to be 2 miles east of the intersection. Is moving at a constant speed of, so this one is moving at a constant speed of 10 miles per hour. So that's 10 miles per hour. And what they want us to do is express the distance d between the cars. So the distance between the cars is going to look like this. Wow, I wrote a straight line there. We're going to call that d. Between the two cars as a function of time. So it's a function of time. So function with respect to time. That means at a certain time, where are these cars according to that time? Let's go ahead and we'll call this one up here D1. You can call it anything you want to, but I want to be somewhat consistent with what the book does, and we'll call that one D2. So the first thing that we really have to notice is that we have a right triangle. And if we remember the Pythagorean theorem from right triangles is that our hypotenuse squared is going to be the same as the two legs of this right triangle, the sum of those squared legs. So it's going to look like this. So D, this is the hypotenuse squared, equals the first leg squared plus the second leg squared. Second leg squared. So it's going to look something like this. These are subscripts down here. They just describe which leg I'm talking about, and these are actually exponents. This actually means that you multiply it by itself. So if I want to take the square root of both sides to get d by itself, I'm going to go ahead and get d is equal to the square root, because I just took the square root of both sides, and d1 squared plus d2 squared. Now you might say, well, Mr. Beckstrom, I thought when you took the square root of both sides you had to put a plus and a minus. But remember, we're talking about distance here, and distance is always going to be a positive value, so I don't have to put the minus there. Because if I had a minus, then we would be looking at a negative distance, and we don't talk about distances as far as negative distances. We can use negative when we're talking about velocity. That means going in the opposite direction. But actual speed and distance, we're going to leave it positive here. So now I've got this function here that I'm building. So d is equal to this and this. And now what I want to do is I want to find out, okay, well, great. That's the distance of the cars right here. And I could actually put the 2 and the 3 in there. So let's see if I did that. That would be 2 squared, which is 4, 3 squared, which is 9. So 4 plus 9 is 13. So that would be the square root of 13. So that's the distance between them right now, would be the square root of 13, which is, what is that? That's like 3.7. I might be wrong. Let me put it in here. So square root of 13, 3.6. So that's about 3.6 miles from each other. But we have to consider that we want to find out what distance they are after a certain amount of time. So notice that they're getting closer and closer and closer to this intersection as the time goes on. So at 0 time, they're going to be here and here. But as we let our time equal like 1 second, they're going to be close, or actually we're talking about hours here. So 1 hour, in fact, they're actually going to be past that at that point. But the idea here is that we're subtracting the distance that they are as time goes up. So what I'm going to do now is I'm going to say d, our distance is equal to, so I'm going to take this d1 here, and for the d1 I'm going to subtract, d1 is over here, so this is 10 miles per hour. So that's going to be minus 10t squared. And remember, this is going to be a function of time. So we're going to subtract that 10t there, and we're going to square it, and then we're going to add the second distance, the d2, but this time we're going to subtract 15 miles per hour, so that's going to be 15t squared. So we've got this big function here. Now we have the numbers for d1 and d2, so let's put those in. So our distance with respect to time is equal to, and I'm just replacing the d1 and the d2, so this is going to be, d1 is 2, so 2 minus 10t squared plus, this is going to be, d2 is 3 minus 15t squared. So we get this crazy number here, and what we're going to end up having to do is we're going to have to multiply all of this out. So these are this is binomial squared, and this is a binomial squared. So I'm going to come down here now. So d of t is equal to, and I'll finish my square root in a minute, but this is, remember, we're using the FOIL method. So first, outer, inner, last. So this is going to end up being 4, because 2 times 2, and then this is going to be a negative 20t and a negative 20t, so that's going to be a minus 40t. And then this is plus 100t squared, plus 100t squared, and that's the first binomial squared, plus, and we're going to do the same thing here, so 3 squared is 9, that's a negative 45, and a negative 45 is negative 90, minus 90t, and that's going to be 15 squared is 225, so plus 225t squared. Now let me go ahead and finish this. And then the last thing that we're going to do, which we are just about out of room, so I will do it up here, is we're going to combine all our like terms. So this is going to be equal to the square root of, so let's do the t squared terms first. So 100 and 225, that's 325. So 325 t squared. And then for the t's, I've got a negative 40 and a negative 90. So that's going to be minus 130t minus 130t. And then for the numbers, the constants, I have a 4 and a 9, so that's plus 13. So this here is our final function. It's a function with respect to time of the distance. Now let's go ahead and put this in our calculator. So clear that out and clear, clear. And we're going to do second square root of, I don't know how I did that, but that's all right. 325. Here, let's clear that part out. All right. So 325. We're just going to call it an x. That's fine. It doesn't matter what we call the variable. X squared minus 130x. 130x x plus 13. Plus 13. All right. Enter. Now, if we were to let's go to zoom, and let's do a zoom fit to see. Is that gonna kind of look like that? Let's go back to zoom standard. So that's not a real great viewing window here. Let's go ahead and go from like -2 to +3. So what I'm going to do here is I'm going to go from -2, change the window, x max to 3, and let's go ahead and graph it down. That's a little bit better here. And let's see what this tells us. Well, if I go to table set, I'm good there, and I'm going to go to table. Let's clear all. Oops. All right, having trouble clearing it. Well, let's leave when t is equal to 0. Look, we got that 3.6. That was that distance between the two vehicles, which is right. Now, what happens when t is equal to 1? Now they're 14.422 miles away from each other. Now remember, they're traveling at 10 miles per hour and 15 miles per hour, which means after an hour, they've crossed that intersection, and now they're going in the other direction. So that's why they're so far away from each other. But that's pretty much the gist of this question here. There's a lot of moving parts to it. You need to make sure we know how to FOIL binomials and set it up like this. And if you have any questions, let me know. And I hope you have a great rest of your week. Thank you.